Welcome back, everybody. We are starting our today's GNF program, and our first session today on the GNF program will start with a keynote of Mr. Jing Peng, Deputy Chief Designer of the spacecraft system of the third phase of China's Lunar Exploration Program, and he is connected with us from remote from Beijing, China. For the audience, I remind you that you again have the chance to engage in the discussion using our Slido system, asking questions. Mr. Peng, thanks for joining us. The floor is yours.
Thank you, Christian. Good morning, ladies and gentlemen. I am Jing Peng from China Academy of Space Technology. Since 2011, I served as Deputy Chief Designer of Chang'e-5 probe system of third phase of China's Lunar Exploration Program. Today, I am very glad to be online to share information about the Chang'e-5 probe. The topic of my presentation is design and the implementation of Chang'e-5 robotic sample return mission on lunar surface. Next slide, please. In my presentation, there is a short introduction about Chang'e-5 mission at first. Then, the summary of technical features and challenges is given after mission is analyzed. In a description of Chang'e-5 probe, it will be given including major specification, configuration, and flight profile. And then the development process of Chang'e-5 probe are described. After that, the breakthrough and the innovation of key technologies such as soft landing, sampling, liftoff, rendezvous docking and sample transfer on lunar low orbit, Transearth Injection are described. The flight result on orbit shows that the function and specification of Chang'e-5 satisfied all requirements, and the mission is a complete success. Next slide, please. Now, at first, let's have a quick overview of Chang'e-5 mission. As a vital step of China's lunar exploration program, the mission goal of Chang'e-5 probe is to implement robotic lunar sample and return. The Chang'e-5 probe consists of an orbiter, a return capsule, a lunar lander, and an ascent vehicle. The objective of Chang'e-5 probe is to implement lunar transfer and circumlunar orbit flight, land on predefined landing site on lunar surface, collect lunar samples, lift off on lunar surface, transfer lunar samples after rendezvous and docking on lunar orbit, Earth transfer flight and re-enter Earth's atmosphere, and bring lunar samples back to ground lab safely at last. Next slide, please. Based on conceptual design, the mission of Chang'e-5 probe was analyzed. There are three major technical features and challenges. At first, the flight profile is very sophisticated. There are different complexes and 6 operation modes in different flight phases for Chang'e-5 probe. There are 119 pyrotechnic devices on Chang'e-5's probe, and the separation between modules for several times. Therefore, the reliability shall be higher. Secondly, the key technologies such as automatic sampling and sealing on lunar surface, liftoff on lunar surface, rendezvous, docking, and sample transfer on lunar low orbit, high-speed re-entry, and the recovery of Earth's atmosphere are very challenging. At last, there are lots of stringent constraints upon the probe design as well as limited resources, such as launch mass. Therefore, the miniaturized and highly integrated instruments are required, and lightweight material is applied in structure and instruments. Next slide, please. Here, then, I'd like to show some detailed information about Chang'e-5 probe. The Chang'e-5 probe consists of 15 subsystems with 655 instruments, 69 software configuration items, and 100 FPGA configuration items. They make up an ascent vehicle, a lander, a return capsule, and an orbiter, which form different complexes in different flight phases. The launch mass of the probe is 8,200 kilograms. The dimension of the probe in launch fairing is 5,400 millimeters in diameter, and the height is 7,100 millimeters. The lateral fundamental frequency of the probe is 6 Hz, and the longitudinal fundamental frequency is about 20 Hz. The accuracy of Earth landing is plus minus 95 kilometers along flight direction, while the lateral direction is 55 kilometers. The reliability shall be no less than 0.65. Next slide, please. Then I'd like to show some diagrams of Chang'e-5 probe configuration. In the first row, you can see in turn the configuration of Chang'e-5 probe in launch vehicle, the solar panel deployed after separated with launch vehicle and en route to the moon. Then the complex of ascent vehicle with ascent vehicle and lander separated with the complex of return capsule and orbiter. Then the last one in first row is the flight configuration of the complex of ascent vehicle with lander on lunar low orbit. In the second rows, it is in turn the powered descent configuration of the complex of ascent vehicle and lander, operation on lunar surface, the liftoff configuration of ascent vehicle with the lander, and the last one is the configuration of ascent vehicle on lunar low orbit. Next slide, please. In this page, in the first row, you can see the in turn the configuration of the complex of the return capsule and orbiter on lunar low orbit before and after the support module of the orbiter is separated. Then the rendezvous and docking of ascent vehicle with the complex of return capsule and the orbit. After that, the last one in the first row is the ascent vehicle separated with the complex of return capsule and the orbiter. In the second row, it is in turn the flat configuration of the complex of the return capsule and orbit on lunar low orbit and moon to Earth transfer orbit. Then the configuration of the return capsule separate with the orbit. The last one is the configuration of the return capsule with the parachute. Next slide, please. At last, you can see the flight profile of the Chang'e-5 probe. After separated with the launch vehicle, it will spend about 5 days in lunar transfer orbit. Then 2 lunar orbit insertion will be performed by the orbiter to insert the complex of the Chang'e-5 probe into 200 kilometers lunar low orbit. On the lunar low orbit, there will be about 2 days for preparation of the power descent of the complex of the ascent vehicle and the lander. After soft landing, there will be 2 days for the complex of ascent vehicle and the lunar lander on lunar surface to finish the sample and scientific exploration. After liftoff on lunar low orbit, there will be 2 days for the ascent vehicle to perform phasing to prepare for rendezvous and docking. And then the complex of the orbiter and the return capsule will perform docking with the ascent vehicle and finish the sample transfer. The canist with lunar sample will be transferred into the return capsule. Then there will be 5 to 7 days for the complex of the lunar orbit and the return capsule to wait for the Transearth window. After the complex of return capsule and orbiter is injected into Moon Earth transfer orbit, there will be another 4 to 5 days for the complex to approach Earth. Then, when the altitude of the complex is about 5,000 kilometers, the return capsule will be separated with the orbiter, and the return capsule will re-enter the Earth's atmosphere and bring the sample back to the Earth. So the whole duration of the overall duration of the Chang'e-5 is about 23 days. Next slide, please. Now let's have a quick review of development process of Chang'e-5 probe. Since 2009, development of several key technologies established a solid foundation for development of Chang'e-5 probe. In January 2011, the Chang'e-5 mission was approved by the government, and the engineering development of the probe was initiated. From January 2011 to December 12, definition of Chang'e-5 probe was established in Phase B. From January 2013 to September 2055, complete design of Chang'e-5 probe was established in Phase C. From October 2015 to November 2020, development of Chang'e-5 probe flight model was finished and ready for launch. On 24th November 2020, the Chang'e-5 probe was launched. Next slide, please. Then, I'd like to share some information about the technical design of important process of Chang'e-5 probe. The first one is about soft landing. To improve the reliability and the safety of lunar soft landing, the design was optimized on basis of Chang'e-3 design. The reliability and the redundancy was improved by applying laser velocimeter and the optical lunar terrain camera, modification of inertial measurement unit backup, and the algorithm optimization of safe zone identification. The control law parameters of powered descent was optimized. The propellant tank was changed to surface tension tank, and the balance pipes were added to improve balance of propellant tank. The landing cushion was optimized too to improve the performance while the weight was reduced. Next slide, please. The second one is about sampling. Two independent sampling methods were designed: a drill, a single rod rotary drill, and a robotic arm with two samplers were designed. The drill can dig in the surface up to 2 meters depth. The robotic arm with two samplers can collect surface samples in a specific area near the lander for several times. The canister for lunar sample can contain two types of sample package to seal them with a leakage rate lower than 4.5 multiple the 9th power of 10 Pascal cubic meters per second. Here you can see the configuration of the complex of ascent vehicle and the lander on lunar surface. On the near side, you can see the robotic arm with the samples, and then the black structure is a diagram of the drill, and then next to the drill, you can see a robotic arm and some components of the robotic arms. On the right, you can see there is a cam for surface sample, and finally all samples collected by the drill and robotic arm will be contained in a canister. Next slide, please. The third one is about liftoff on lunar surface. During preparation of liftoff, the initial reference is determined by ground support, autonomous positioning, and attitude determination by ascent vehicle. The connection of ascent vehicle and lander is separated before liftoff. When the main engine of ascent vehicle is ignited, it will lift directly, and the attitude control will be induced after 1 second. Then it will ascend directly for 10 seconds and be injected into a 15 kilometers multiple 118 kilometers lunar low orbit by control law. The plume of the main engine vehicle will be diverted by a plume version device on the top surface of the lander, and the interference of the plume effect was analyzed. Next slide, please. The fourth one is about Rendezvous docking and sample transfer. There are two phases for Rendezvous of ascent vehicle with a complex of orbiter and return capsule. The first one is performed by ascent vehicle. After the ascent vehicle is injected into lunar low orbit, it will perform 4 trajectory maneuvers by ground command to raise the altitude of the orbit, correct bias of the orbit plane, and inject it into a 210 kilometers circular lunar low orbit. When the complex of the orbiter and the return capsule is 50 kilometers behind the ascent vehicle, it will perform autonomous guidance and control to approach ascent vehicle to achieve docking condition in about 3.5 hours. Next slide, please. There are 3 gripper dock mechanisms which will grab the beams on the top surface of the ascent vehicle to connect the complex of orbiter and return capsule with ascent vehicle. Then the racket transfer mechanism will transfer the sample canister into return capsule. There will be a cabin in return capsule for the canister. Next slide, please. The last one is about Transearth injection. In order to meet the requirement of Transearth injection window, two trajectory maneuvers on lunar low orbit were designed to make the complex orbit of orbiter and return capsule arrive at right position 0 window. Because the complex mass of orbiter and return capsule is less than 2,000 kilograms after separation with ascent vehicle, while the thruster of main engine is about 3,000 newtons, two Transearth injection maneuvers by 150 newtons thrusters were designed to inject the complex into Transearth orbit to avoid disturbance on flexible solar panel of the orbit. Next slide, please. In the last part of my presentation, I'd like to share some implementation results of Chang'e-5 probe. At 24th November 2020 Universal Time, the Long March 5 rocket liftoff at 21:06, about 36 minutes after the liftoff of the rocket. The Chang'e-5 probe was separated with the launch vehicle. At 12:24, 29th November, lunar orbit insertion was performed. The second lunar orbit insertion to insert the probe into 200 kilometers lunar low orbit. At 2040, 29th November, the complex of the lander and ascent vehicle was separated with the complex of orbiter and the return capsule. In this slide, you can see in turn the picture of liftoff, separation of the probe with launch vehicle, the deployment of the solar panel of the orbiter, and separation of the lander, the complex of lander and ascent vehicle with the orbiter and the return capsule. Next slide, please. On December 1st, the complex of the lander and ascent vehicle was landed on lunar near side, 51.9 west longitude and 43.1 degree north latitude. Before the drill worked, the lunar penetrator radar on the lander explored subsurface structure. Then the drill dug about 1 meter's depth. Before the robotic arm was deployed, the infrared spectrometer on the lander explored the lunar surface to be sampled. In the coming 16 hours, the robotic arms perform 12 times digging to collect the lunar surface sample. Here you can see in turn the picture of a distant camera, the drill, and the canister for lunar sample. And on the bottom right is a picture taken by the monitoring camera for the robotic arm collect surface sample. Next slide, please. On December 1st, support module of the orbiter was separated on lunar low orbit. Then at 50:10, December 3rd, ascent vehicle was lifted off on the lander. At 21:42, 5th December, ascent vehicle was docked with a complex of orbiter and the return capsule. At about 22 o'clock, the canister was transferred into return capsule. At 4:35, 6th December, ascent vehicle was separated with a complex of orbiter and return capsule. At 23 and 30, 7th December, ascent vehicle impacted lunar surface at 0 degree east longitude and 30 degrees south latitude by ground control. In this slide, you can see a picture of liftoff's ascent vehicle approaching of the ascent vehicle with the complex of the orbiter and the return capsule. Then the third picture is image of the grab docking mechanism. The last one is the canister which was transferred to the return capsule. Next slide, please. At 13th December, the complex orbit of orbiter and return capsule was inserted into transfer orbit back to Earth. At 17:13, 6th December, return capsule was separated with orbiter. About 40 minutes later, the return capsule was landed at 111.5 degree east longitude and 42.3 degree north latitude in Inner Mongolia and recovered sooner, less than 1 hour. After separation, 2 trajectory maneuvers were performed by orbiter to transfer to the Sun-Earth Lagrange point 1 for extended mission. Next slide, please. Next slide, please. On 12 o'clock, 17th December, the return capsule was shipped back to Beijing. The canister with lunar sample were extracted, weighed over 1,700 grams. Lunar samples were collected and transferred to scientists of National Astronomical Observation, China's Academy of Science. They sealed the canister with a suitcase filled with nitrogen. By the end of December 2020, the lunar sample return was taken out from the canister and they were categorized in special ground lab. On January 2021, the regulations on lunar sample management was claimed by China National Space Administration, encouraging applying study of lunar sample returned by Chang'e-5 probe. Next one, please. The Chang'e-5 probe has achieved many major breakthroughs, including sampling and sealing, liftoff on lunar surface, rendezvous docking, and sample transfer on lunar orbit, and the re-enter Earth's atmosphere with lunar sample in China for the first time. The complete success of Chang'e-5 mission conclude China's lunar exploration program. As China's most sophisticated space project, the success of Chang'e-5 mission is another major achievement of China's space industry. It will contribute to deepening the understanding of the origin of the moon and the evolution history of the solar system. That's the end. If there is any question or interest, I'd like to try my best to share more information about Chang'e-5 probe. Thank you for listening. That's all.
Thank you very much, Mr. Peng. I mean, this is really a very detailed and most interesting insight in all the details of this internationally most recognized mission with a very, very complicated and very complex scenario. So we've received so far one question from the audience, and I'm happy to give this to you. The question is, the Chang'e-5 orbiter is now at Sun-Earth Lagrange point 1. Are there plans to visit a near-Earth asteroid or other targets?
Okay, thank you. The extended mission of Chang'e-5 orbiter is still under planning. We haven't decided whether it will go back to the moon or go further into solar system to visit asteroid and other celestial bodies. But I think because there is few propellant left in the tank of in the propellant tank of the orbiter, so I don't think it will there will be many opportunities for the orbiter to perform much to perform more complex orbit maneuvers to visit other bodies. I think it will stay in Lagrange point one or the Moon Earth system. It's still under planning. I think there will be some claim after the extended mission is decided. Thank you.
Thank you. I would have one question concerning the analysis of the samples. Is this done exclusively in China, or are you also engaging international scientific community for the analysis of the returned samples?
Any more questions, Christine?
Yes, I repeat my question. I was asking about the analysis of the samples. Is this done exclusively in China, or do you engage and involve also international scientific community?
As I know, the agency is willing to promote international cooperation on sample research, but because I am not the member of the to decide whether the sample is given to any institution or some research institute to do the research. So I am not very sure about whether it's now have any opportunities for international cooperation in case of the lunar sample. But I think in the regulation of the lunar sample management claimed by the agency, there is no limit for the applying to study of the study the samples by some countries or institutes. Maybe you can find more information in the official website of the agency or the China's Lunar Exploration Program Office. There might be some more information about the application of the lunar sample study. Thank you, President.
Yeah, thank you for this information. I mean, I have another question here from the audience that goes in the same or in a similar direction, which says, from the samples returned to Earth compared to the data from the Apollo mission, are there any differences in terms of geological properties? I don't know whether this would also be a question for you, whether you can answer that or refer us to any other source to get the answer to this question.
You know, I am an engineer of spacecraft, so I'm not very familiar with lunar sample, but I have seen the samples by my own eyes and talked with some scientists in China Academy of Space Science. I think the basic property of the samples is almost the same with the samples returned by Apollo. But some scientists told me that the age of the sample might be younger than the samples returned by Apollo program. I think there will be more results in the journal or some or scientific magazines to in the future after just I think maybe 1 week ago there is a review few conference in China for the application of the lunar sample. Maybe someone will get some new findings about these samples after a period of time of study of these samples. Thank you, Christine.
Well, thank you very much for this reference to this interesting conference, and I'm sure this will be interesting also for the international community. I would like to close the session here. Once again, thank you very much for all your detailed information, which was very much appreciated. I would like to also take the opportunity, as we are connected to Beijing, to convey to you on behalf of the International Astronautical Federation our sincere congratulations to the successful launch of Chang'e-5 earlier today with 3 astronauts, which I think is another great achievement of China. So please accept our congratulations, and we look forward to a successful mission of this crew. With this, I would like to close this session. Thank you, Mr. Peng, again for connecting with us. And we will continue with our GNF program here in the room in a few minutes with another very interesting session organized by Airbus Defence and Space. So if you bear with us for a few minutes to just reset the stage. Thank you.
Thank you, Christine. Bye-bye.